So this is a reminder. These are Taylor series and here's Maclaurin series. The only difference is Maclaurin has the value of A equals 0 and Taylor is the more in general one. All right. So here's different kinds of problems to do the Taylor or these series with. So let's do the Maclaurin series on this. So first off, again, remember you're always writing the function first. I'm going to rewrite this as 1 plus x to the negative 1. I don't want to use quotient rule. I want it nicely written so I can do easily the derivative. So I'm going to take the derivative with chain rule. So I get negative 1 plus x to the negative 2, and the derivative of the inside is just a positive 1. Second derivative. So this negative 2 comes down, so it turns into a positive 2. 1 plus x to the negative 3, and again, the derivative of the inside is just 1. Third derivative is negative 3 times 2, 1 plus x to the negative 4. And again, I like to do 4 derivatives. So I don't join the numbers together, but anytime I have negative and a negative, I change it to be a positive. So I don't have a whole bunch of negatives hanging around. But leave the numbers unmultiplied so that you can see the pattern. All right, so let's plug in 0. So if I plug in x equals 0, I get 1. Put in 0 into the first derivative, I get negative 1. Put in 0 into the second derivative, I get 2. 0 into the third derivative, I get negative 3 times 2. And 0 into the fourth derivative, I get 4 times 3 times 2. So you recognize that 4 times 3 times 2 is 4 factorial, correct? Because that's the same as saying 4 times 3 times 2 times 1. So we'll be using factorials a lot. So let's start by putting together our Taylor series. So there's going to be our Maclaurin series. 1 is the first number, plus negative 1x over 1 factorial, plus 2x squared over 2 factorial, minus 3 times 2x cubed over 3 factorial, plus 4 times 3 times 2x to the 4th over 4 factorial. And it keeps going. Okay, so again, this is, I want to be able to plug in 0, 1, 2, 3, 4 into my sum, correct? So almost every single time the sum is going to start at 0. So let's look at this one to get an idea of what's going on. The first couple of terms are not too helpful. So I see a 4 factorial and I've got n equal 4. So it looks like I'm going to have an n factorial in the denominator. Looks like I've got x to the n going on, right? Third term gives me n equals 3 here. So that's going to work. Looks like I have a 4 factorial for n equal 4, a 3 factorial for n equal 3, so a nice n factorial here. And then I have the changing sign. Remember, if it's changing sign, it's going to be this or this. So I'm always going to start with this. Does it work? If I plug in n equals 0, I get a positive 1. That looks like it works. Let's double check it. If I plug in n equal 1, I get a negative, and that works. So this is it. All right, let's go do another one that's a little challenging. So again, f of x is ln of x. Always write that first. Then take the derivative, and again, I'm going to rewrite this so that it's ready to do a power rule the next time. Third derivative is positive 2x to the negative 3. Remember to get rid of the negative signs, right? The negative times the negative is a positive. And then this is a negative 3 times 2. So don't multiply the numbers together, but eliminate the negative signs. So now go plug in 1. This is Taylor series, so I'm plugging in 1. ln of 1 I know is 0. F prime of 1, that's putting in 1, I get 1. Second derivative, I get negative 1. Third derivative, I get a positive 2. Fourth derivative, I get a negative 3 times a 2. All right, so the function will equal 0 is my first term, plus 1 x minus 1 over 1 factorial minus x minus 1 squared over 2 factorial plus 2 times x minus 1 cubed over 3 factorial plus a negative 3 times a 2, x minus 1 to the 4th over 4 factorial. Okay, so I can get rid of this. So let me clean it up a bit. So I'll have x minus 1 minus x minus 1 squared over 2 factorial plus 2 times x minus 1 cubed over 3 factorial minus 3 times 2. Okay, so you have options here. You could work on simplifying this first before you go and try to make up the sum, or you can leave it as it is. If I wanted to simplify it first, so these first two terms, nothing happens, right? Those stay the same. So this here, 3 factorial, and here's a 2. You know that 3 factorial is 3 times 2, so the 2 would cancel. So all I would be left with in the denominator would be the number 3. And then this here, 3 times 2, you know that 4 factorial is 4 times 3 times 2. So the 3 times the 2 would cancel. So all I would be left with in the denominator is 4. So let's go back and investigate this. 2 factorial. Isn't 2 factorial the same as saying the number 2? It is. So I can get rid of, my eraser's not working, I can get rid of the factorial. So it's just 2. Okay, so let me write the answer up here. So I want to be able to plug in n equals 0 to get this. N equal 1, n equal 2, n equal 3. So if I plug in n equals 0 to get, or let's just go to this one here, n equals 3. So it looks like that would be n plus 1 in the denominator, right? It would be x minus 1 to the n plus 1. And again, I've got this alternating sign. So what happens if I start with n equals 0? Does that give me the positive? It does. So this is a fine answer. Someone else, let me just write it, might want to start at 1. These are both acceptable answers. So this would be my first term. This would be my second term. This would be my third. So this is one of the cases that this works for because I start off with x minus 1 to the first power. So if I was to use n equal 1, I could make it x minus 1 to the n. And on the denominator, I would have n. And then I would have to take into account that alternating sign. If I put negative 1 to the n, that wouldn't work, so it'd have to be plus 1. So this or this, they're both equivalent. It doesn't matter which one you use. And most of the time we do start at 0 because it's nicer, but this one, it can work because I start here at 1.